Hello, we have to perform the experiment of sensors and actuators, MTE 3633, lab number 3. We are using the DIGIAC 1750 instrumentation trainer, but here we have to study the circuit here. We will be using the photoconductive cell or the LDR. We have to study the circuit here. How is it connected? And how to simulate it using another software. And we have to plot the characteristic of the LDR on this table. And you will see the characteristic curve of the LDR. Here on our practical exercise, we have a connection here. It is connected from the 12-volt source to the potentiometer. This is a wire-wound track, and the output of the potentiometer is connected to the power amplifier, and the output of the power amplifier is connected to the phototransistor. And then this circuit is only to give power to the phototransistor in order to give light to our LDR, so that the LDR could respond to the light given off by the phototransistor from 0 to 10 volts. So we have to adjust this from 0 to 10 volts, and the voltmeter will read the voltage of the supply voltage given to our phototransistor. And then the LDR is connected to the 5 volts with a drop resistor of 3 kilo ohms. We will know it because here, according to the instructions here, it will be adjusted to 3 kilo ohms. This is the equivalent circuit. So we have the 5 volts here, supply, and then it's connected in series to the 3 kilo ohm resistor. And then we have the LDR connected in series. And we have the output voltage here. And this voltage, this is the output that we will put into the table. Now here, the lamp filament voltage from 0 to 10 volts. So what will happen if you will put a voltage on the phototransistor, and it will be received by the LDR according to the intensity of the light that it is given off. What is the voltage output here? Will it increase or decrease? Now you can check within the circuit connection here. So we have an LDR, it's connected in series with a 3 kilo ohm resistor. So if the light falls on the LDR, the resistance of LDR will decrease. So as the resistance decreases, the voltage also will decrease here. That is our assumption. So we have to check this with the actual circuit, but in this case we will be using a simulation software in order that we can check the characteristic of the LDR. So we will connect now the circuit. So we have here the graph. Okay, so we will take the voltages from 0 to 10, and we have to record the voltage output across the LDR, and we have to plot the characteristics here on this blank table. But instead of this table, we'll be using here on the Excel, so that the waveform can be, or the characteristic curve can be shown here on the side. So We will now create a circuit just like this one. So I will use this nice software, and I will take an LDR. We have the torch and the LDR here. So I will use this torch, and I will click OK. And we need also a resistor, which is 3 kilo ohms. You have to select the maximum power of the resistor. This is not important. We need only the package, what resistor we will be using here. So here this is 3 kilo ohms. I will click on this, click OK. Okay, so I will put the resistor here. I will rotate this, and I will put an LDR. Now this point I will put a 5-volt supply there. This 5 volts is the power symbol, and on the bottom we will connect it to the ground. Then we will put a voltmeter across the LDR. Okay, connect the other side, and it will. Okay, so this is our voltmeter now. So in this simulation, we do not need that other part of the circuit here, this one, because this powers only the phototransistor that will give light to the LDR. But here we have already this source of light, so we will have to decrease the distance of this source of light to the LDR so that we can simulate the intensity for the LDR, and then we will read the voltage output. So it's the same thing that we are increasing from 0 to 10 volts, and proportionally we will have to decrease the distance of the lamp to the LDR. Okay, so here I will okay. Okay, so I will make this smaller so that we can see the value, and we can put the value. Okay. Okay. So we'll start the simulation. Okay. So let us say if there is no voltage here, the maximum voltage here, of course, if this LDR has a really big resistance, very big resistance across its terminals. So this will be having a 5 volts output here without a source of light. Okay, so I will put here, for example, 0 volts, and I will put here 5 volts. Okay, okay, so we have here lamp voltage filament is 0, so the voltage at this point will be 5 volts. Okay, So this one, we will consider this as 1. Okay, but there's already a voltage here, which is 4.98. Okay, so I will consider this as 1. Say, for example, this is 1 volt or a 1 unit. Okay, so there will be 10 units for the distance, and the voltage here, according to to our reading here, is 4.98. So I will put here 4.98. Okay, so it is automatically plotting our coordinates there. Okay, or our pair. It's automatically plotting on the Excel sheet. So first one, and then the voltage is 4.98. So this is the second one. 2, which is 4.93. So this is 2, and this is 4.93. Okay, so then 3, that is 4.85. So 3 is 4.85. And then 4, that is 4.72. 4.72. And 5 is 4.35. 4.35. And then 6, that is 3.85. 6 is 3.85. Okay, then 7, 3.12. 7 is 3.12. And then 8 is 2. And then 9 is 1.25. And then 10 is 0.71. Okay, so this is the last value. We cannot increase it further. So this is the nearest value, or that is equivalent to 10 voltage supplied to the phototransistor. So this lamp source is actually our simulation of the phototransistor, but it's not the circuit is not needed to be reflected here. The source of light is enough, and the distance um, between the LDR and the lamp source. So here, this is our uh, characteristics of our LDR, the response of the LDR in accordance to the light that falls onto its surface. So as the voltage or the intensity of the lamp is increasing, the resistance decreases, and therefore if the resistance decreases, the voltage also across will be decreased. The voltage across will be decreased also. So this is our plot that we have obtained on our experiment. So according to this plot, we can check the value. Say for example, for 3 volts, how much voltage here on this point. Okay, so you can approximate the value here in accordance to the plotted edition. Thank you.